everybody. We are going to pull it all together today and relate problems, tables, equations, and graphs. Before we get started, you need to have some graph paper, you need to have a straight edge such as a ruler, and you have to have a pencil, not a pen. Never going to graph in pen. So if you need to, stop the video. Make sure you have these supplies here. I don't want you making your own graph paper by, drawing out all the little squares. It has to be actual graph paper. So let's get started. Let's look at, get myself a little better organized here. So this is very, very similar to a problem that we worked on earlier in the week. In fact, I just changed the numbers. So number one, and you are doing this with me, a large pizza costs $12. Orders of wings are $2. Write an equation using C for total cost and W for numbers of orders of wings. Your equation will model the purchase of a single pizza with orders of wings. We are also going to make the table of values, and we are also going to graph that equation. So let's see. If we are starting with the pizza cost of 12 and the orders of wings are each $2, what's the rate of change? The rate of change is $2 per order of wings. So the cost of the pizza equals the $12 plus the $2 per order of wings. And let's make our table. So this will be, actually that's a little close to my equation. Let me do this. So this will be orders of wings, and that will be cost. So I can have 0 orders of wings, and my cost will be $12. I could have 1 order of wings. That would be 14, right? The rate of change, it's right there. The rate of change is 2, so it's increasing by 2. And so on until we run out of toppings, or I should say until we run out of orders of wings. So let's graph this equation. So you must use a straight edge for your axes. They have to be very carefully on a blue line. And I'm going to have to see if this shows up for you. Yep, it does. Okay. So this is going to be my orders of wings. And this over here is going to be my cost. So the first thing I need to do is think about what numbers are going to go along these lines. Well, the orders of wings seems easy to me. So 0 orders of wings is going to be this right here, 0, 12. And then it will be 1, 2, 3, 4, and so on. Now, what about here? I can't just start 12, 14, 16, 18, 20. If I want to count by 2s up here, I have to count by 2s down here. So I can go 2, 4, 6, 8, 10, 12, 14, 16, 18, and so on. Okay, so this is very important. At time 0, right? That's now. At time 0, this point ends up on the y-axis. I can't put 0 here. 0 goes at the origin. So it will be 0 orders of wings for $12. And because it's on the y-axis, we call that the y-intercept. So 1 topping is 16. 2 toppings, 1 topping is 14, 2 toppings is 16, 3 toppings is 18, and so on. Now, When you're connecting your dots, it's not going on at forever in both directions. It's starting at 0, 12, and then heading out from there. Why does this line not go in this direction? Because over here would be negative orders of wings, right? This is positive orders of wings, and over here would be negative orders of wings. Any point that I graph in this area in quadrant 2 is absolutely meaningless. So my first point is 0, 12, and then it can go on from there. So this is my meaningful table based on the problem, and this is my meaningful graph based on the problem. Let's look at a second one. Okay, a gas tank currently has 10 gallons of gas in it. At the gas station, the pump adds an additional 5 gallons per minute. Use G for gallons in total and M for minutes. So we're going to write our equation, we're going to create the table of values, and then we'll do the graph. So, where's my rate of change here? 5 gallons per minute, which means my rate of change is 5 per minute. So the total number of gallons will be equal to the 10 I started with plus an additional 5 per minute. And let's make our table. So how do you decide which one goes where, gallons and minutes? If you have time, it always is going to go over here. All right, so now at 0, the tank has 10 gallons. At minute 1, because the rate of change is 5, and here's our rate of change, positive 5. It's going to go up by 5 each time. So in 2 minutes, I'll have 20 gallons, and so on. All right, let's graph. So you're using your straight edge. And let's see. Remember how I said if you have time, it's going to go over here? If you have time, it's going to go along the x-axis too. So this is my minutes, and this is my gallons. Let's see. 0, 1, 2, 3. That makes it easy. 0, 1, 2, 3, and so on. Now again, if I want to count by 5s, that's great. And because the rate of change is 5, right? The rate of change is 5, and we're adding 5 each time, it makes sense to count by 5s. But if I want to count by 5s, I have to count by 5s the whole way up the y-axis. So I'm going to go 5, 10, 15, and so on. Okay. Again, at time now goes right on the y-axis. This is 0 minutes right here. And at 0 minutes, I had 10 gallons. At 1 minute, I had 15 gallons. At 2 minutes, I had 20. At 3 minutes, I had 25. Now again, when I connect my dots, it starts at 0, 10. There's no such thing as negative time. There's no negative minutes over here. So it starts at 0, 10, just like my table did, and continues. Now obviously when the tank is full, you can't add anymore. But with this type of problem, it's okay to show that it's going on if you don't know the limit of the tank. Okay, so there's that one. And let's do one more that's a little different, and then I'll give you your independent one. So a hiker is climbing down a mountain. Right now, the hiker is at 2,400 feet and will descend at 200 feet per hour. Use E for the hiker's elevation and H for hours. So let's see what we've got here. Where is the rate of change? Is it 2,400 per something or 200 per something? It's right here. And that's how I know the rate of change, 200, is going to actually be 200h in my equation. So the hiker's elevation, E, equals the 2,400 I started with. Descend means go down. That is a negative rate of change. And I box that in, you can see that that's a negative rate of change. So here we go. Let's do our table. Again, if you've got time, it goes on the left. And let's see, this will be the feet. At time 0, right now, the hiker is at 2,400. 1, 2, 3. So it's a negative rate of change. It's going down 200 per hour. So this is 2,400, then 2,200, just subtracting 200 each time. 2,000, 1,800, and so on. All right, let's do our graph. Putting my axes carefully on my graph paper. And let's see. I need to be able to get up to 2,400 on this. Thinking, what should I count by? Can I count by 200s? 2, 4, 6, 8, 10, 2, 4, 6, 8, 20, 2, 4. Yep, if I make this a little taller, I have room. So let's see, time always goes here. 1 hour, 2 hours, 3 hours. This right here is elevation in feet. And we said we're going to count by 200, so 200, 400, 600, 800, 1,000, 1,200, it's getting messy, 1,400, 1,600, 1,800, oh my goodness. Okay, now I'm ready for my y-intercept. Remember, time now always appears on the y-axis. So at time 0, right now, that hiker's at 2,400 feet. At time 1, hour 1, he or she is at 2,200, and so on. Hour 2 is at 2,000, hour 3 is at 1,800, and so on. So since there's no negative time, I am going to start my graph right here, and why am I ending it right there? Why am I not putting an arrow on this? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What happened after 12 hours? This is the point 12, 0. What does that represent? It represents that at 12 hours, the hiker has 0 feet left to climb down. The hiker is at the bottom of the mountain and can go no further. So this graph actually has a starting point and an ending point. Okay, I am going to give you your independent one. Here it is. A Hollywood makeup artist charges $50 per hour and $150 for supplies. Use C for total cost and H for hours. So you're going to write an equation. You're going to make a table of values. And you're going to create a graph. If you're not sure about your equation, let me know. I can check it for you before you get started on the rest. Take care.